Calculus video 29, the chain rule. So we've done the product rule, the quotient rule, the power rule, taking the derivative of e to the x, taking derivatives of trig functions. We are now going to do the chain rule, which is probably the most difficult of all of the rules for derivatives for calculus. And what it's going to do, it's going to allow us to take the derivative for functions such as this. So we had f of x equals the square root of 2x squared plus 3x plus 1. Or g of x equals e to the x to the third. Or h of x, another function to the third. How about sine to the third of x? Or k of x equals 5x squared minus 1 over x in parentheses, 5 over x. Well, if I could read right. How about 5x squared minus 1 over x squared, or m of x equals 6x squared over 2x squared plus 5. That looks like quotient rule, but then squared. Or finally, something like j of x equals cosine of 5x squared. All right, there's, 6 functions that we will need the chain rule to solve. So what do these functions have in common? What is it that's unique about these functions that the ones prior did not have? These functions are examples of what we call composition of functions, a function inside of another function. Right? Back in algebra, we had composition of functions. Composition of functions. And a lot of times in algebra, people are like, why are you making such a big deal about compositions of functions? Well, here's one reason why we make such a big deal about composition of functions. So it's a function inside of another function, such as f of g of x. Right? F of g of x, where we have like an inside function g of x and an outside function f of x. For example, in that very first one up there, f of x equals the square root of, and maybe I'll make that something else besides f, so it's not confusing with the f we're going to see in a minute. Let's call that, what don't I have here? How about b of x? B of x is equal to the square root of 2x squared plus 3x plus 1. We have an inside function, 2x squared plus 3x plus 1, and an outside function, square root of x. All right, so we have b of x equals the square root of 2x squared plus 3x plus 1. The inside function, this is the inside function. That's like the function. That is like the g of x. Whereas the outside function, the square root part, right? The square root part, that is like the f of x. Or we might see it like this. You have f of x is equal to the square root of x. G of x is equal to 2x squared plus 3x plus 1. Right, those are two functions. If we were to do f of g of x, what we would do is we take the entire the entire g of x function, 2x squared plus 3x plus 1, and plug that in place of the x. And so instead of square root of x, we get square root of 2x squared plus 3x plus 1. That is a composition of functions. It's the square root of replacing the x with the entire g function, 2x squared plus 3x plus 1. Anytime you have a composition of functions and you want to take the derivative of it, we have to use the chain rule. Must use the chain rule when taking the derivative of a composition of functions. Right? Must use the chain rule when taking the derivative of a composition of functions. So here it is. What is the chain rule? Chain rule. Big star. We'll use this one all the time. Let's suppose, right, that means suppose. Let's suppose that we have a function h of x, which is equal to a composition of functions f of g of x. Right, the g for the inside function, the f for the outside function. What is its derivative? Tell you what it's not. H prime of x is not equal to f prime of g prime of x. You can't simply take the derivative of each one. It doesn't work out. Instead, what you do is this. Suppose h of x is f of g of x, then h prime of x is equal to f prime. So we take the derivative of the outside function. That's like the square root function in that previous example, right? It's f prime of the original g of x function times. So there's more to it. So, but just going back up here, so we have kind of an idea to think about. We have this square root function. Now the squares we often write as an exponent of 1/2, right? So another way to think about this is you're picturing 2x squared plus 3x plus 1 to the 1/2 power. Okay, so the 1/2 power is like our outside function. We take the derivative of that, right? So like we bring the 1/2 down, and then that new exponent is 1/2 minus 1 negative 1/2. But we don't take the derivative of the inside at this point. We leave the entire g of x function, right? We leave it 2x squared plus 3x plus 1. It is the derivative of the outside function f prime of, not times, of the g of x, of the original g of x. Times, then multiply that result by g prime of x. And that is the chain rule. Chain rule. If h of x is a composition of functions, f of g of x, then h prime of x is f prime of g of x times g prime of x. Let's walk through that example fully. So we had b of x is the square root of 2x squared plus 3x plus 1, which we will again rewrite as 2x squared plus 3x plus 1 to the 1/2 power. Right, that is the function b of x. To take its derivative, if I can leave that up there, to take the derivative b prime of x, I want the outside function. So you're just picturing, literally what I'm picturing here when I do this is like, I'll rewrite that in a second, but just like some blob. I have a blob to the 1/2 power. The derivative is I'm going to bring the 1/2 out front times my blob to the negative 1/2 power. The blob doesn't change. It looks something like this. We'll bring the 1/2 out front times blob to the negative 1/2. That is f prime of g of x. Now that inside blob, it doesn't change in this portion. It is what it is. So my blob was 2x squared plus 3x plus 1. It's going to be 2x squared plus 3x plus 1 here. You're not taking the derivative of that inside function yet. We're leaving it just g of x. So this part that we've done so far, right here, this is f prime of the g of x function. The derivative of the outside, but the inside function stays exactly as it is. And then multiply that by g prime of x, the derivative of the inside. So what's the derivative of that inside g of x function? Well, 2x squared plus 3x plus 1, the derivative there is 4x plus 3. And that is the chain rule. F prime of g of x times g prime of x. And if you wanted to simplify this, you might say, since that's a negative 1/2 power there, I might call this 4x plus 3 divided by the 1/2 out front. We can just get a 2 down here, and then a 1/2 power, but it's negative, so we'll bring it down to the bottom. Square root of 2x squared plus 3x plus 1. Right? Might look a little bit better, but also this was a fine answer too. Right? One of those two. Okay, let's try some more. I listed 6 problems at the very beginning. Let's just run through all those problems and just practicing understanding our chain rule. So the next one I had was g of x. And again, I may stray away from using g of x since I have a g prime in my chain rule. Let's change that to c of x is equal to e to the x to the third. So e to the x is a function, right? It's not just a number. And so when I think of this, my inside function is that's the g of x, that's my e to the x. My outside function is something to the third, blob to the third, right? The function here we're talking about, h of x is equal to f of g of x, with my f function, f of x, being like just x to the third, something to the third, and my g of x that gets replaced in for that x is e to the x. All right, so this is kind of algebra separating the composition of functions into its two functions. So when I write f of g of x, what I'm doing is I'm taking that e to the x right here, and I'm putting it into the function, the x value of the function. And so we get e to the x to the power of third, with the e to the x going in and replacing the x. So now that I have this, the outside function being the f of x equals x cubed, the derivative of that, right, we're thinking, again, I'm going to erase, I'm going to put a blob, I'm going to come back. We've got some blob to the third. The derivative of that is I'd bring the 3 down, and then it would be blob squared. So c prime of x, I'll bring the 3 down, it's blob squared. Okay, but don't just have blob, we actually have e to the x there. So e to the x to the third, we'll bring the 3 down, that becomes e to the x squared, and then we need to multiply that by the derivative of the inside function, by g prime. So this first part here, that is f prime of g. This second part here is g prime, and maybe this is the greatest second example because what's the derivative of e to the x? Is itself e to the x. So we end up with this. 3 times e to the x squared times e to the x, which is 3 times e to the 2x, right? An exponent raised to an exponent, you can multiply those exponents, times e to the x. And if you take the same base, e to the 2x times e to the x, you actually get 3e to the 3x here. So that would be the derivative. The derivative of e to the x to the third is 3e to the 3x, or if you like it better, 3e to the x to the third. That one can actually be done a little bit easier. If we look at c of x, instead of looking at it as e to the x to the third, if we go ahead and multiply those exponents and call it e to the 3x from the very beginning, okay? So now my kind of switching this up here, my outside function here now is e to the x. My outside function is e to the x. My inside function is the 3x. And what I'm doing is I'm taking the 3x and plugging it in for all the x's of the f function, which becomes e to the 3x. So because f of x is now the outside function, what is the derivative of e to any power? The derivative of e to any power is itself. So this is like f prime of g. You need to multiply that, though, by the g function, which is the 3x, by the g prime. The derivative of 3x would just be 3, and either way you look at this, you get 3 times e to the 3x. Same answer. Okay, keeping going here. How about sine cubed of x. H of x equals sine cubed of x. We write sine cubed like this, like the third degree of sine, because if we write it like this, it's kind of ambiguous. Are you talking about the sine of x, the whole function there being cubed, or are you just talking about the x being cubed? And because of that ambiguity, we don't write it like this. We just leave it like this, saying it's the sine function being cubed. But what we mean by sine cubed of x is it's the sine function that is being cubed. And a lot of times when you're doing derivatives, it's helpful to write it like this, sine of x, parentheses, being cubed. What we can see here is that my outside function, f of x, outside function is something cubed. In this case, I'll just put the x there, x cubed. My inside function is the sine of x. Because if I were to replace all the x's with the g function, this entire sine of x would go right here, and I would get sine of x that is being cubed. So to do the derivative, h prime of x, I'm going to take the derivative of the outside function. That's like my x to the third, or you can think of it like this. Sine of x cubed, that's like blob cubed. The derivative of blob cubed is we'll bring the 3 down, then we have blob to the second power. Except it wasn't blob, it was sine of x. Then the reason I use the blob is I'm trying to say whatever is here, whatever it originates as sine of x, doesn't change in that portion when I take the derivative. It stays the same. But then we multiply that by the derivative of the blob. Multiply it by the derivative of sine of x. The derivative of sine of x is cosine of x. So this first part here, that is f prime of g, and the second part times g prime. And if I were to write this out, I would say that h prime of x, is 3 sine squared of x cosine of x. I would rewrite it, instead of sine of x in parentheses squared, I would rewrite that as sine squared of x, our kind of conventional notation. All right, moving on. Let's do k of x equals 5x squared minus 1 over x. All raised to the power of 2. All right, pause the video. Try it yourself. See what you can do with this one. Okay, if I'm looking at this, I'm looking at my outside function as something squared. My inside function is 5x squared minus 1 over x. Because if I were to take this inside function and plug it in for all the x's, I would have my composition of functions. So my outside function is x squared. So when I do k prime of x, derivative of the outside function, the 2 comes down, and then it's whatever I have on the inside to the power of 1. That part doesn't change. Times, now we're going to multiply it by the derivative of the inside. And the derivative, the derivative of 5x squared is 10x minus, let me pause, I probably should have done this a minute ago. 1 over x is the same thing as x to the negative 1. Kind of side work over here, right? 1 over x is the same thing as negative 1. The derivative of x to the negative 1, bring the negative down, negative 1. Now it's x to the negative 2. So when I do the derivative of 1 over x, it should be negative 1x to the negative 2, which then the 2 negatives cancel out, makes this plus x to the negative 2. Or let's see, this would be 2 times 5x squared. First off, I want to rewrite that as x. Yeah, let's do this. Let's do x to the negative 1 times 10x plus x to the negative 2. And let's go ahead and FOIL that out to distribute those two terms here. So my 2 is just going to hang out. 5x squared times 10x is 50x cubed. 5x squared times x to the negative 2. X squared times x to the negative 2. You add the exponents. 2 and negative 2 make 0. X to the 0 is just 1. So 5x squared times x to the negative 2 is 5 times 1, which is just 5. Same thing's going to happen here. negative x to the negative 1 times 10x. X to the negative 1 times 10x to the first. You add the exponents, x times x to the negative 1 times x to the 1. Add those, that's x to the 0. That's 10x to the 0. That is just 10. But I believe it was negative 10, if I'm not mistaken, because of the negative sign there. So minus 10. And then minus x to the negative 1 times x to the negative 2 is x to the negative 3. And we get this. 2 times 50x to the third minus 5 minus x to the negative third. And if you want to distribute the 2 in there, you're more than welcome to do so. But this looks like a pretty good answer. The only other option I might consider, if I didn't like this answer, and I want to simplify further, is to do 50x to the third minus 5 minus x to the negative third, is to, put that over 1, multiply top and bottom by x to the third. And the reason I'm picking x to the third is, what I do is I go through and I look, what's my greatest negative exponent? Right here. And to get rid of it, I need to multiply it by x to the power of the positive version of that. So in this case, x to the positive 3. This is if you don't like negative exponents in your numerator. So if you go through and distribute, you get, you still have the 2 kind of hanging out here. You get 50x to the 6th minus 5x to the third minus x to the negative third times x to the positive third is x to the 0, which is just 1. And then on the denominator, you just get x to the third. So this is also maybe a little bit better answer, but I would take either one. Okay, 2 more. 2 more and we'll be done for this video. The more practice, however, you can get with the chain rule, the better. It's one of those things where you can understand it, okay, f prime g times g prime, but until you do like 50 problems or 70 problems, it just isn't always quite there. So I really encourage you to practice a lot with these problems. Here we have m of x is equal to 6x squared over 2x squared plus 5. All raised to the power of 2. Okay, so I have a quotient on the inside and this power on the outside. The outside, that's my outside function. I have something squared, right? If you're picturing this as I have some blob squared, the blob being my inside function. So the derivative here, again, I have something squared. The derivative is I bring the 2 down. It's that something now to the power of 1. So m prime of x is, bring the 2 down. It is that 6x squared over 2x squared plus 5 to the power of 1. But then I have to multiply that by the derivative of the inside. All right, this part is f prime g. I need to multiply that by g prime, the derivative of the inside. But the inside is a quotient. So in order to do g prime, I must use quotient rule, because the inside g function is a quotient. And the quotient rule is this. It's the derivative of the numerator, 12x, times the denominator, 2x squared plus 5, minus, you leave the numerator, the derivative of the denominator is 4x, over the denominator squared. So it's times all that. All right, let's see if we can simplify it all. On the g prime part, that quotient rule, I'm going to distribute the 12x, and I'm going to multiply the 6x squared and 4x together. All right, so this whole part here, that is g prime. So we have, just write the first part out again, 2, 6x squared over 2x squared plus 5, all raised to the power of 1. Well, it's to the power of 1, so I'm just going to leave it. And then times 12x times 2x squared is 24x to the third. 12x times 5, 60x. Minus 24x to the third. 6 times 4 is 24, x squared and x to the third. Over 2x squared plus 5 squared. And we notice something nice happens here. We get a 24x cubed, negative 24x cubed, those cancel out. I have 2 times 6x squared times 60x over 2x squared plus 5 to the first, right, that's this one right here, times 2x squared plus 5 squared, which is 60 times 6, 36, 360x cubed, 2 times 360x cubed over 2x squared plus 5 to the third, right? 2x squared plus 5 to the first times 2x squared plus 5 squared is 2x squared plus 5 to the third. And maybe it's not worth having that 2 out front, so 720x cubed over 2x squared plus 5 cubed. Or if you do want the 720 out front, you can write it like this: 720 times x over 2x squared plus 5. And since both of those exponents, the x is being cubed and the 2x squared plus 5 is being cubed, you can put that as one fraction and then cube the whole thing. I don't care. That one's fine. That one's fine. Those are all good answers. All right, last one. G of x is equal to the cosine of 5x squared. Sometimes the hardest part about these problems is identifying what's my outside function, what's my inside function. Take a minute, try it out yourself. Pause the video, come back to it. Okay, I am seeing the outside function here as the cosine of x. And the inside function is 5x squared. And the reason is, if I were to take the 5x squared and plug it in for the x into the outside function, I would have the cosine of 5x squared, which is my original function. So the cosine is the outside function. The cosine is the outside function. The cosine is the outside function. So g prime of x here is the derivative. Again, I have multiple g's. I don't like that. Let's call it d and d prime. My apologies. D prime of x. I'm taking the derivative of the outside function. What's the derivative of cosine? The derivative of cosine is negative sine. And here's an example of what not to do. It's not negative sine of and then take the derivative of 10x. Although I'll see that a lot, we don't do that, right? We think about it like this. We think about it like, instead of 5x squared here, you're thinking blob. I have the cosine of something, cosine of blob. The derivative of the cosine of blob is negative sine of blob. But we didn't have blob, we had 5x squared. That 5x squared is still 5x squared right here. We're not taking the derivative of that at that point. We multiply it then, now times the derivative of the inside. We multiply it by the derivative of 5x squared, which is 10x. And we end with negative 10x sine of 5x squared is our derivative. Okay, that's the chain rule. There's 6 examples with the chain rule. We'll try it in a little bit different format in the next video.